Hello everyone. I am Muhammad Shuaib, final year student from Department of Electronic Communication Engineering, studying at Rajiv Gandhi University of Knowledge Technologies, Rajiv Knowledge Valley from Andhra Pradesh. Being a part of MXC Embedded System Internship Program, we have successfully completed projects on in the guidance of Rajini ma'am. This project is built in a group of three members, me along with my friends Virendra and Vamsi. Now I am here to demonstrate the micro oven simulation project. So let us see the overview we have learned in 4 weeks internship. So the topics covered in internship. So we have go through the basics of C programming language and learn about the microcontroller and introduction to embedded system, introduction to the project, what we have had doing the project and what are the steps that need to follow to implement the project and, and Disha workshop. So let us go to the C introduction. C is a middle level procedural programming language. Main features of a C language is general purpose and portable, low level memory access, fast speed, clean syntax. C is versatile. It can be used in application and technologies. If you know C, you will have no problem running other popular programming. She is mother of all languages. Topics we have learned in C: data types, int, integer, character, float, and double. Modifiers, signed and modifiers are signed and unsigned, size, short, long, long, long. Loops for while and do while. Jump statements, go to, break, and continue. Decision statements such as if, else, switch, case, and default. Other Others we learn wide, return, size up. So go to next slide. Functions. A function is a group of statements that together perform a specific task. A function declaration tells the compiler about a function name, return type, and the parameter. Primary purpose of function is to break up complicated computations into meaningful chunks and name them. So let us go through the pointers. A pointer can be used to store the memory address of the other variable. Use of pointers allow low level memory access, dynamic memory allocation, and many other functionality in C. So, example many types: white pointer, null pointer, for pointer, dangling pointer, and will pointer. So let us go through the microcontroller. Let's see the picture of microcontroller. A microcontroller made on a single semiconductor chip is called single chip microcomputer. Since single chip microcomputer are generally used in control applications, they are also called microcontrollers. Microcontroller contains all essential components of a microcontroller computer, such as CPU, RAM, ROM, EPROM, input and output lines, etc. Some single chip microcontroller contain devices to perform specific functions such as DMA channels, analog to digital converters, serial port, pulse width modulation, etc. So let us go through the next slide. So, what is the difference between microprocessors and microcontroller? So, see that microprocessor is heart of computer system. Microcontroller is a heart of embedded systems. Since memory and input output has to be connected externally, the circuit become large. In microcontroller, since memory and input are present internally, the circuit is small. Cost of entire system increases. In microcontroller, cost of the entire system is very low. Most of the microprocessor do not have power saving features in microprocessor. In case microcontroller, most of the microcontrollers have power saving modes like idle mode and power saving modes. This helps to reduce power consumption even further. Microprocessors have less number of registers, hence more operations are memory based. In microcontroller have more number of register, hence the program are easier to write. In microprocessor, mainly used in personal computers only. Such as microcontroller used mainly in washing machine MP3 players. So go to the next slide. Embedded systems. Embedded system is a combination of any hardware and software which is intended to do a specific task. A general purpose system GPS is used to perform large number of tasks and embedded system is used to perform a specific task. Main components of embedded systems are software, hardware, and firmware. Applications: digital clock, elevator, washing machine, microwave oven, and so on. So let us go through the next slide. Embedded system structure: sensor, analog to digital converter, processor, digital to analog converter, actuator, memory. In memory, we have RAM memory, ROM memory. So advantages of embedded systems. So first thing is it has low power consumption, cost efficient, and efficient use of processing power, reliability, efficient use of memory. Types of embedded systems. So see that first thing is stand-alone embedded system, second real-time embedded system, third networked embedded system, and fourth mobile embedded systems. In standalone system, these systems are not intelligent even though these are embedded systems. This system cannot take action by their own. Example, semi-automatic washing machine. And this considered in slave system, independent system. This system can take action by their own. Example, Google car. Next, real-time system. These systems are time-bound system which will take action on a specified time. In here, failures in the system are not acceptable, such as hard real-time, firm real-time, soft real-time. Example of real-time system is airbag system in car. Network system. The systems which are connected to network is called network system. Example, home security system. Mobile system. The system which are movable are called mobile system, such as robots. So next continue my friend Vamsi Kumar.
Hi everyone, I'm Vamsi. I'm going to introduce about the project. While coming to the project, we have built a project based on MPLab XIDE simulated on the software named Picsimlab. We worked on the project that is microwave oven simulation. Nowadays, many people prefer microwave oven for their daily use as a common kitchen appliance for eating, previously cooking cooked foods and cooking variety of foods. Microwave oven is used to heat the food using microwaves, which is or form electromagnetic waves. There are several modes in various microwave oven. We are going to implement in four modes. First one is micro mode, and second one is grill mode, and third one is convection mode. And these all are Use a start button to start the microwave oven. To move ahead with a micro mode, this mode is used to cook food in traditional manner. And this and in the project, we have built the maximum power has 900 watts. And this micro mode oven used to cook in a traditional way. Is the maximum time that you can set for cooking 60 minutes. And second one is grill mode. The grill mode is used to cook bread and meat. It works as a micro mode, but the purpose is to cook meat and bread. User can set time as per the cooking time of meat. And third one is convection mode. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. After is done, then the user can set the time as per the requirements. And these are the requirements which you use for the project. The main things is we have a good knowledge in embedded C and MPLab X IDE civil software and by the XC8 compiler and Picsimlab. In Picsimlab, these are the ports which we are observing in here in the screen. PIC16F877A microcontroller, 16 by 4 CLCD, and tactile switch with the matrix keypad, timer, buzzer, and fan. So, Embedded C. Embedded C is a set of language extension for the C programming language to address common issues that exist between C extensions for different embedded systems. Embedded C programming typically requires non-standard extensions to the C language in order to support enhanced microprocessor features. So this is the difference of C programming and embedded C programming. Mainly that C programming, which is an basic programming, but the embedded C is the advanced version of C programming. This is in C programming independent of hardware architecture, but in embedded C programming dependent on hardware architecture like microcontroller or other devices. Mostly C programming is used for desktop applications, operating system and personal computer memories. But embedded C programming used for the limited resources like RAM, ROM and other peripheral on embedded controller. And these are the materials and software used for the project microwave oven. And the software used is MPLAB XIDE with the X8 compiler and Picsimlab to simulate the output of the project. And the hardware is not only the big and the hardware is only the Picsimlab. In this Picsimlab having PIC16F877A microcontroller, an LED module, fan module, matrix keypad module, tactile key module, 16 by 4 display to display the output of the project. And this is the MPLAB XIDE software that we are using in the project. This MPLAB XIDE is a software that is MPLAB Code Configurator is a pre-graphical programming environment that generates seamless, easy to understand C code to insert in your project. Create a project in MPLAB XIDE. Ensure MPLAB XIDE is aware of your compiler toolchain by selecting tools. And these are using by the X8 compiler. The X8 compiler is integrated with MPLAB XIDE to provide you full graphical frontend. Editing errors and breakpoints match the corresponding lines in the source code. And this is the architecture of Picsimlab. So the main was which you were using the microcontroller is PIC16F877J. And this is the GPIO, general purpose input and output. And these are the RTC and EEP ROM. And this is LM35 time sensor. And this is the analog to digital conversion. This is the CLCD display. And this is the matrix keypad. And this is digital keypad and buzzer, LEDs and RS232. This is the microcontroller pin diagram of PIC16F877J. In our project, X16F877A microcontroller is used. It has basically 40 pins. First 20 are arranged in left side as we can observe in this figure and other 40s are at right side. It makes easier to use with the peripherals as the function are spread out over the pins. Due to these pins, it is easier to decide what external devices to attach without worrying too much if there are enough pins to do the job. So this is the microcontroller pin diagram of my PIC16F577J, and this is the simulator which we are using, that is Picsimlab. In Picsimlab, there is CLCD display, and these are the matrix keypad, like is called is like a tactile switches, and this is the fan, and this is the buzzer, and this is the main microcontroller which we are using PIC16F877G, and these are the ports, port D and port B. These are arranged in a order like B0 to B7 and D0 to D7. These are not only nothing but these are LEDs only. So CLCD. CLCD stands for Character Liquid Crystal Display. In Piximlab, there are two types of displays. One is 16 by 2 display and another is 16 by 4 display. But in this project, we are using 16 by 4 display. Main advantage of using CLCD is instead of 7 segment display and other multi-segment LEDs is that there is no limitation in displaying characters. It displays ASCII character and some special characters. It is mostly commonly used in displays. Two types of communication modes are 4-bit mode and 8-bit mode. But in our project, we are using 8-bit mode. So this is the structure of the not. I mean, this is the CLCD display. This is 16 by 2 CLCD display, and this is 16 by 4 CLCD display. Tactile switch. A tactile switch is a whose operation is perceptible by touch. This touch used to select the mode of operation and to enter the temperature and to enter the time in our project. The switch will produce a bouncing effect when switch is pressed. Tactile switch allows the current flow when the actuator is pushed on the held. There is minimal travel of the actuator. So this is the tactile switch, and this is terminal, and this is metal plate. So this is a pull down resistor circuit, and this is pull up resistor circuit. In pull up resistor circuit, if the switch is open, then control is read to 1. But if the switch is closed, then control read to 0. But in pull down resistor circuit, if switch is open, control read to 0, and the switch is closed and control read to VDD. This is the matrix keypad. Keypads. These all textile switches are arranged in a rows and columns like a matrix. So that's why this is called as matrix keypad. So MKP that we stands in a short form. This is the keypad in which number of tactile switches are connected in a row and column as I told you now. This is used when more number of users input are required and still want to save some controller input output lines. This keypad are most commonly used in telephones, calculators, digital lockers, and we are using this project also. Interrupts. An interrupt is a common process set up in a microcontroller in which an internal or external device requests the MPU or MCU, means microprocessor unit and microcontroller unit, to stop the processing. Then the microprocessor unit or microcontroller unit acknowledges the request and attends to the request, goes back the processing where it was got interrupted. So these interrupts are classified into two types. One is software and another one is hardware. But again, the hardware is again subclassified into two types, maskable and non-maskable. And these maskable are subdivided into two types. One is external and another one is internal. Polling. It is the process where the computer or controlling device waits for an external device to check readiness or state, often with low-level hardware. There is some disadvantage of polling. This is loss of events may occur during polling and poor response and less power management. ISR. ISR stands for Interrupt Service Routine. An ISR is software that is hardware invokes in response to in an interrupt. ISR attends to request of an interrupting source by the clearing the interrupt flag and should have save register contents that may be affected by the code in ISR. It must be terminated with the instruction retrieve. When an interrupt occurs, the microprocessor unit completes the instruction being executed, then it disables global interrupt enables. Places the address from the program counter on the global interrupt enables. Place the address from the program counter on stack. Timers. Timer is an important application in an embedded system which is a default peripheral which maintains the timing of an operation async with the system clock or external clock. It has many applications such as measuring the time and generating delays, etc. Timer or the counter is a software designed to count the time intervals between the events. Resolution, which is also called register with 8 or 16-bit etc. Tick is referred as the change from one number to the another number. It may be up count or be the down count. Quantum, which depends on the system clock setting, is measure of time, which is responsible for the tick. And the scaling may be pre-scalar or post-scalar. But the next demonstration of project will be given by my friend Virendra.
Hello, I am Virendra. Coming to the main part of the project, that is actual simulation of micro oven using Picsimlab. And this is the MPLab XIDE where we develop our project. That means the code where we have written. First of all, we have included all the libraries which is required and we have provided all the types of variable initialization. And we have initialized the modules that is required in the main.c, and we are using switch case to determine all the conditions, all the covering modes in it, cooking modes in it. We also declared all the functions that is required in the main file. Now coming towards the end, everything mentioned in the while loop so that our code will run continuously. Now, let's build this project and see what the output was. Yes, as you can see, the build is successful. Now, let's see the simulation in the Picsimlab. Yes, this is the Picsimlab, and here we can see 16 into 4 CLCD display. These are the matrix keypads, and these are two arrays of LEDs from D0 to D7 and B0 to B7. This is the buzzer. This is fan. These are the switches which were used in this project, and this is the PIC 16F877A microcontroller which has 40 pins. And I now let's see the simulation in this. First of all, we have to load the hex file. I will load the hex file. So as soon as I load this hex file, the power on oven screen will be displayed. And these are the four modes of operation of microwave oven. First mode is micro mode. If the user press key 1 from the menu display, the micro mode will be activated. As soon as user click the key 1, power information of 900 will be displayed in the CLCD. And the set time screen will be next, where we prompt the user to enter the number of minutes and seconds to be run in micro mode, and the star key used to clear the current minutes and seconds, and the hash key is used to enter the next process. And let me give the minutes and seconds. I will give 12 minutes and 50 seconds. Let me enter this. Yes, the micro oven is started. It will display the time. The timer will be running in a decremented value till seconds to be 0. After that, buzzer is on. And here, key 5 is used to pause the whole operation. Here you can see the fan is off, time is off. And to restart this or resume, we can press number 4. And 6 is used to stop the entire process. Let me click key 6. Yes, here it can come back to the menu display. This is micro mode. Coming to the grill mode, if user press key 2 from the menu display, the grill mode will be activated and the set time screen will be displayed. Yes, you can see the set time screen. In this also same as it is in the micro mode, star will be used to clear the minutes and seconds. Hash key will be used to the enter to the process. Here also we can give minutes and seconds and enter to start the next process. I will give 40 seconds and 15 minutes. Let me enter this. Again, the grill mode will be activated. Time will be running in a decremented mode till 0. Here also 5 but key is used to pause and again 4 will be used to restart the program and 6 will be used to stop the entire process. I'm coming back to the menu display. This is overall about grill mode. Next mode is convection mode. If the user press key 3 from the menu display, the convection mode will be activated and the set time screen occurs where the user is prompted to set the temperature for preheating in the convection mode. Let me say this. Yes, here you can see the set temperature screen. In this, we can give the temperature what we want. I will give 140 degrees. And here also, star key is used to clear the whole temperature and then hash key is used to enter to the next process. Let me enter this. Yes, the set time screen will be displayed after preheating. The oven is preheated for the given value and then set time screen will be displayed and this here also we can give the amount of minutes and seconds. Let me give 10 seconds and enter to the process. We can listen the buzzer sound after completing this. Yes. After the time is completed, it will show the time up and buzzer will be sounded beep sound and coming back to the menu display. This is all about convection mode and the last mode is start mode. If the user press key 4, start mode will be activated and the same time display screen will be appear as the user press number 4 key. Here the default time will be 30 seconds. It will start decrementing from the default 30 seconds. The fan is turned on. If you want to increase again 30 seconds, we can click number 4. You can see the increment of 30 seconds. And 5 is used to pause. And 6 is used to stop the entire process and coming back to the menu display. Yes. This is the overall simulation of microwave oven project. Yes. Coming to the conclusion, what we had gained and learned in this internship is we have learned how to use MPLab XIDE, how to compile with the help of XC8 compiler, and how to simulate on Picsimlab. And we are introduced to different software along with the interface and real-time experience. At last, in the Disha workshop, we had gained knowledge of what is our core domain and what is the future in it. And finally, I thank you, Emertex Technologies, and the whole team of Emertex for providing wonderful opportunity of internship. And specially thanks to the Rajni ma'am and Anusha ma'am and each and everyone in the Emertex team. Thank you.